All right, this is part 4, and this is the last problem of our midterm box sorting questions. As you can remember, in part 1, we went over momentary start, stop, push buttons. And in part 2, we went over the zone conversions using the real weight. And in problem 3, we went over the box counting and the weight as the box was distributed in each zone. So in this problem, we are using the light curtain safety sensor that detects unsafe intrusion into the conveyor area. When the light curtain is triggered, an alarm horn must sound and a light must flash for 0.5 seconds on and 1 second off. If the alarm is triggered for more than 5 seconds, the conveyor must be stopped, meaning killing all power. And pressing start with no alarm condition will allow the conveyor to start again. So it is our job to make a function block here. And before we go to live action, we're going to go and actually see this function block. It's going to be right here. This is our problem 4, problem 1, problem 2, 3. And now this is our fourth and last function block, as it's labeled light curtain alarm. And so we can see how it's connected to the conveyor and how it's labeled. We have so first you can see mainly how it's connected to the conveyor is by our horn alarm going into our horn, our lamp going into our lamp, and our conveyor stop going into our start, stop, and run conveyor stop, which I will show you in just a second. And then so we have our light curtain indication here as our output, going all the way up here to our light curtain as input. And so one of my problems was getting this to go was I did not have this light curtain negated. So it wouldn't even flash. My start wouldn't even go. So that was a big problem for me, and I'm glad to overcome that and understand why I did it wrong. And so if we go to we have this all explained, so we can go to our curtain sensor in ladder diagram, ladder diagram, and you can see how the first network we have our light curtain, and we can see our values right here and what they are. I'll show you my variables first. So this is my variables: light curtain, bool, horn, lamp, conveyor stop, and timer on, along with a blink. So seeing how this actually flows is the light curtain goes straight to the horn alarm. So that's our first network. So that is our first network, and as our horn alarm is our last coil. Going down to the second network, the alarm horn enables blink right here. Just hit enable, causing the lamp to blink on and off. So it'll just flicker, and you can see our time low, we have it set as 1 second, and our time high as 0.5 seconds or 500 milliseconds. So going down after that goes off. You go down to our third network, and so the alarm horn just stays on, causing blink to blink the lamp. And as soon as alarm sounds, the timer on. So this is our light curtain. Let me explain that. And as soon as the alarm sounds, the timer on is counting up to 5 seconds, as we have right here as our PT. Once reached, it will go to the conveyor stop. And as you can see, going to the main where our function blocks are, we have our light curtain connected directly to our start, stop, and run conveyor stop. And so if we go to our EQT, EQU start, stop, run, you can see that we have a conveyor stop listed right here along with our variables right here, and this is negated or normally closed. So once the timer on reaches 5 seconds, it will activate this conveyor stop, killing all the power. So if we can go back to our visualization, we can show you how this is supposed to supposed to activate and how the alarm and horn will go off. So we hit start. We got a little bit of that. Okay, so we're running here. We got our boxes sorted. So I know we need to speed up and speed down our speed to get an indication of our alarm. Oh, so just like that, as soon as we moved it just barely, it should kill off. And okay, there we go. So the light was on for 5 seconds and it was off for 1 second. And all that was going for 5 seconds and the power was completely killed. Lights were off. Conveyor stops. And so if you were a real-time operator using any of this box order sorting deal, if you were working there, right? You don't want to be messing with anything. You don't want to be messing with the packages. You don't want to deal with risk, especially when it's getting injured. So the alarm makes the Box Genie more safe, more efficient to use, especially with indicating an alarm and having it turn off within a certain amount of time. It definitely shows you when something bad is about to happen. So that is my problem 4, and this is the last video of my midterm.